We'll do a review day. It'll be fine. But don't just blow it off, okay? It's a 4-day weekend. Huh?
It's really sunny.
That's JV, and I already know since you committed that you're not JV. It's enough. It's gonna be great. It's gonna be great. All right, guys. To see the deadly bacteria. And then do they die?
Yes.
To deadly. And you're gonna watch it?
Yes.
That sounds terrifying. Shelby, did I put Shelby to deadly bacteria?
Yes.
151. Okay, guys, listen. Okay, it's almost a 4-day weekend. Let's learn some stuff. Okay, let's learn some stuff. Come on, guys. No, we're not gonna. I literally wasn't here because I didn't come to school that day because I didn't want to. Are you serious? Yeah. I mean, I kind of like felt a little bit sick. So, too sick. Yeah. You've done it. Okay. All right. So, get out your Chromebooks. We're gonna do, since I didn't see you Monday or Tuesday, we're gonna do a little homework example just to remind you of how to do your homework. Okay. So, if you will, please, I'll put mine up there. Okay, pull up your homework for today. And you're going to already have some of it done before we even start the notes. How incredible. That sounds great, doesn't it? What? Okay, once you have your homework up, please just open the very first question. The very first question. Okay, what is it asking you for? It gives you a vector, it's like 6, 9, I think, or 9, 6, or something like that. What does it ask you to find? Okay, it asks you to find the magnitude. You remember that the magnitude is how long the vector is? You remember that? Yes or no? Yes, hopefully you do. Oh, sorry. Well, you will soon. There we go. There we go. Okay. So the first question, look at it. It says this. Okay, so let's review how to find magnitude. And the reason why is because this lesson today goes with what we did last time. So if you don't understand that, you're going to be confused today. Okay, so magnitude is how long the vector is. So do you remember the formula for magnitude is a squared plus b squared, and then you take the square root. Do you remember that? So in this case, if my vector is 6, 9, then this is my A and this is my B. So I would do 6 squared plus 9 squared and then take the square root. Okay, now in your calculator, do that. What is 6 squared plus 9 squared? Should be 100 and something. 100 what? Okay, 117. Can you square root that? Okay, no. Now you do have to pay attention on your homework. If it says exact value, that means you're not allowed to round it. So you need to actually type in the square root of 117. So if you don't remember how to do that, you're going to pull up your little keyboard, bloop, take the square root, bloop,
and then 117. Okay? So magnitude is how long the vector is, a squared plus b squared, then take the square root. Okay, then go on to the next question. Okay, so root 117 is the answer to number 1. Okay, go down to number 2. Now we're going to find the direction of that vector. So let's review how to do that. A direction is the angle that the vector's at. So remember, you're going to do tan theta equals y over x. Now, what would my y over x be for this vector right here? 9 over 6. So I do tan theta equals 9 over 6. And then how would I cross out the tan? Remember? You do the inverse tan. So in your calculator, type in the inverse tan of 9 over 6 and tell me what your degrees are. And then round it to the nearest whole number. What was it? 56? Okay. So then you would just type in 56 and that would be your answer. Okay, you should already know how to do those two things. I'll show you here. Second tan of 9 over 6. And I get 56. So yeah, that's right. Okay, do we remember how to do that already? Okay. So that being said, let's come over to your notes and we're going to add some new stuff to this. Okay, but you should already hopefully know how to do that. Okay. All right, so first page. If you have, let's say that I give you a vector like 9, 6, the one that we just did. Okay, I'm going to start on the back side here. And I said, okay, draw vector 9, 6. You would be like, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. That would be your vector. And then if I asked you to find the magnitude, you would do it just like we did. Remember, magnitude is how long it is. And we got 117 square rooted. Okay, the other thing that you could find would be the direction. So remember, the direction is the angle right here, and our theta came out to be 56. Okay, that was the direction. Okay, what we're going to do today is we're going to learn how to do that backwards. So instead of you knowing the vector at the beginning, you're going to know how long it is. You're going to know the angle, and you're going to have to go backwards to find this. Okay? So take a look at the front page, and you're going to see two formulas. Okay, if you know the magnitude, which is how long it is, okay, and the direction, if you know those two pieces, you can go backwards. Thank you all. Using this formula right here, this is going to be your A. And then this is going to be your B. Now, just to clarify two things, theta is your direction. And then the little double bars, do y'all remember what that stands for? This thing? Do y'all remember that that's how long it is? And that's how long it is. Okay, so what is going to make the notes today take a really long time is if everybody's not paying attention until like the 4th day. So we have a 4-day weekend. We're going to review Tuesday, Wednesday, and you guys have a test Thursday, Friday. So I'm not telling you that to scare you. I'm just telling you that because if you blow off the whole class period, I'm not going to be the one that's stressed when you take your test. It's going to be you. Okay, so let's put the phones to the side. Let's do a little bit of focusing right now so that we can all be on the same page. Okay, all that you need is the link and the theta. So look at this one right here. It says vector V, that's this. Vector V has a length of 8 and a direction of 210. Then you can write the vector yourself by putting the length in front of cosine for the x, sine for the y. So look at what that's going to be. It would be 8 cosine 210 and then 8 sine 210. Okay? Then from there, you're going to use the unit circle to find the exact value for those numbers. remember that cosine is the x value, and then the y value. So can you find 210 degrees on your unit circle? What quadrant is it in? 210. Quadrant 3, it's right here. There's my ordered pair. And then I'm going to plug in the x for cosine and the y for sine. We already know how to hopefully do the unit circle. So it's going to be 8 cosine. What's my x? Look at the circle. Right there. Negative root 3 over 2. And then for my sine, I'm going to plug in the y value, which is negative. So it'd be 8 times negative. Okay, and then from there, remember, numbers inside the square root can only go with other numbers on the inside. Numbers on the outside can only go with other numbers on the outside. So if I were to do this one, I have 8 times by a negative and then divided by 2. What's the new number in the front? 8, turn it negative, divided by 2. What would I get? Negative 4, and then the root 3 just kind of goes by. Okay, because remember, if the 3 is in the root, it can't go with the 4. It's on the inside, the other one's on. Okay, but then for this one, what is 8 times negative a half? That would just be negative 4. Okay, and that would be your vector. Now, if I asked you to graph it, okay, then here's what you would do. You would draw your little coordinate thing, and you would go to the left, whatever 4 root 3 is. So I'd go this way, and then I'd go down 4, and then I'd draw my vector. Now, look at the vector we just drew. Is it pointed the same way as 210 on the unit circle? Yes, those should always match. So if you ever end up with like, maybe like a positive and a negative, you would go like, oh, positive, negative, I'm pointed the wrong way. So you should be able to tell that your vector here, okay, your 210 degrees matches with where the 210 is. Okay? All right, let's do another one like that. This is where it's going to get a little bit weird, and we're going to bring in some other subjects. So the first one is going to be cardinal directions. So look at your compass here. You should have done this in science, I guess, geography. Okay, but we're going to basically lay this on top of the unit circle. So if I always start my angles from here, what direction would that be on the compass? East. So I want you to go to east. This is my start, which means that's 0 degrees. What about if I was headed north? Look at the circle. How many degrees would north be? 90. Okay, then in between that, you would call this direction what? Do we remember? North, east. And it would be perfectly between north and east, which means that it would be 45 degrees. Okay. Now, what if I rotated all the way around to be facing west? How many degrees would west be on the compass? 180. What about if I was headed south, perfectly south? What would that be? 270. Okay, and then we need to fill in the other 3 of the had-see directions. So for example, if this is north and this is west, what would the middle be? Northwest. And how many degrees would it be on the unit circle? Look for the one that's perfectly in the middle. 135. Okay, what about southwest? Southwest would be perfectly between west and south, so it's here. How many degrees would that be? Look up at your circle. I want to go straight down the middle. Then I would want 225. Okay, we have one more left. What are we going to call it? What direction? Southeast. And what angle would it be? 350 now. Okay. So what's going to be a little bit different is that most of our questions today are going to be talking about cardinal directions. Okay, but if you just lay it on top of the unit circle, it's the same thing. So look at the question. It says we have a force, we have a wind. going 10 miles per hour, southwest. What direction is southwest? Look at the compass we just drew. What direction is southwest? 225. Okay, and then the 10 miles per hour, that's going to be the length. Now you know the two ingredients that you need. So here's what you would write. The force equals. So I'm going to do my little F with the little half arrow to show that it's a vector. And then I would say 10 miles per hour is how long it is, times the cosine of 225. And then 100 miles per hour times the sine of 225. Okay, but remember that that formula is always the same. The first number is how long it is. And then the second number is whatever your theta is, which would just be your direction. Yes, ma'am. Huh? Oh, sorry. Yes, it is. I put 100, sorry. Yes, you're right. Okay, so the first number is going to be the length of the vector, which was 10. And then the second number is 10. Okay, then from there, you're just going to look at your unit circle and then pop these values. So look at your circle. What is the cosine of 225? Negative what? Negative root 2 over 2. And that's the x value on the circle. Okay, what about the sine of 225? Look back at your thing. Negative root 2 over 2 again. Which for us is good because if they're the same, then that means we have less to, we just work it out once and we'll know both. Okay, remember, numbers on the outside can only go with other numbers on the outside. So what is 10 if I turn it negative and then I divide it by 2? What's the number in the front number? Negative 5. So my vector would be negative 5 root 2. And then what would this one be? Negative 5 root 2. And then if you wanted to graph that, make sure that you end up in the right quadrant. What would I do? I would have gone to the left, negative 5 root 2 over 2, and then I would have gone down, and then I would have ended up down here. Is that the same as southwest? Then we know that we did it right. Okay, so your final vector should match the same basic position as the direction that you're wanting to point. Okay, overall makes sense? Okay, now obviously, okay, the world doesn't work where you're always perfectly north or perfectly south or perfectly southwest. Okay, so turn the page. Okay, we're going to talk about how you describe all of the other directions besides the perfect middle ground. Okay, so we're not going to work out all of these, but we're just going to work out a couple of them. Let's say that you wanted to be pointing north 30 degrees west. Okay, circle that. Here's what that means. Draw your little compass. Y'all do never eat soggy waffles? Okay, I heard never ever smoke weed. Okay, you can remember that one. Doesn't matter. Okay, but never eat soggy waffles. What are the degrees for perfectly north? 90. And then what you're going to do is, if it's north 30 degrees west, you're going to tilt 30 degrees this way. So if this is already 90, and then I tilt 30 degrees towards the west, well then what would my direction be if I have to start from here? Well, remember, I have to go the long way, so I have to start here. I'll go 90 just to get to north, and then I'll have to go 30 more than I'd be at 120. Does that make sense? Okay, so your direction for that would be 120. Because remember, you can't measure just from north. You have to always start from that east, the start point. Okay? All right, now let's look at, and then from there, how fast is this vector going? It says, what's the length? 100. Then your vector would be 100 cosine 120, and then 100 sine 120. Okay? And then you would look at the unit circle, pull the numbers in, blah, blah, blah. Okay, next one. Next one says we're doing south 30 degrees east. south 30 degrees east. So draw your little compass. Which way am I going to start off pointing? South, which is how many degrees? It was 270. But then which way am I going to tilt 30 degrees? Towards east. So think about east is over here, then I want to go 30 degrees this way. So what would my direction be if I have to rotate all the way around to 270 and then 30 more? What would my direction be? 300. You get how to do it? Not too bad. Okay, so your direction would be 300. Okay, now, quick question. What if instead of tilting 30 degrees east, I had tilted 30 degrees west? Instead of adding the 30, what would I have done? Subtracted it because I would have been stopping before 270. Does that make sense? Okay. So what I want you to do now is turn to question 6. Okay, most of your homework, okay, are sets of word problems where it's broken down like part A, part B, part C. Okay, so we're going to work through number 6 and then one more, and we're going to take really good notes so that when you do your homework, okay, you know exactly what you're doing on each step. Okay, so the whole point of vectors, okay, is that you can use them to model real world situations. So let's say that you have a jet that's going 40 degrees east of north at 400 miles per hour. We're going to write a vector for the jet. Okay, so jet equals, how fast is the jet going? 400 miles per hour, so I'll do 400 cosine and then 400 sine. Okay, then the other thing I need to know is what this angle is. That's where I'm going to analyze this thing right here. So look what it says, 40 degrees east of north. So let's draw our little compass here. How many degrees is perfectly north? 90. But then I want to go 40 degrees east of that. Which way is that? To the left or to the right if I want to go to the east? To the right, yes, sorry. I was looking at that. So I would be wanting to tilt this way 50 degrees. Now remember, you have to start from here. So do I add the 50 degrees to the 90 if I want to reverse back towards the start? Subtract them. What's my direction? And 90 minus the 50 is 40 here and 40 here. Okay. All right, so we did our jet. Now we need to do the wind. Okay, your jet's not flying through a vacuum. It's got wind that's being acted on it. So it says it's going through a wind stream. The wind is flowing 30 degrees west of north at 50 miles per hour. Okay, well, the 50 miles per hour is how long it is. So I'm going to put wind equals 50 cosine something and then 50 sine something.
Yes.
Yes, subtracting by
Wasn't it 40?
40.
Yeah.
Subtracting by 40.
It's a long year. Okay, thank you. This was 40. So then 90 minus 40 makes this. I'll take my ear. I was listening to that song. The cookies are messing up the bad. So we'll. Okay. So we did 400 cosine 50, 400 sine 50. Now we're doing the winds. Okay, the speed is 50, but we need to know the angle. So what does it say right here? 30 degrees west of north. So I'm going to draw another one. Okay, north, south, east, west. And then if I want to go 30 degrees west of north, I'm tilting towards the west. Do I add 30 or subtract it? Add it. And so if I add 30 to 90, what's the direction of the wind? 120. Okay, that's going to be step 1. Then on your homework, you're going to literally type in this one first with the comma, and then you'll type in this one second. Okay, then you'll have parts A and B already answered. Okay, the next thing that you're gonna do, so that's step 1, is you're gonna add the vectors. Now, when you add the vectors, do you remember the rule that you add the x's with the x's and then the y's with the y's? So in your calculator right now, add these two and then add these two. Okay, but remember, you can only add vectors, the x with the x and the y with the y. We're going to do it in here though, so that we don't have to use the unit circle. Okay, so ready? 400 cosine 50 plus, and then my bottom one was 50 cosine 120. There's my x. Okay, then I'm going to type in my y's. So I want 400 sine of 50 plus 50 sine 120. There's my y. Okay, so I'm going to write that down. That's the next step. So you write the vectors. Okay, then you're going to write the combined vector. So it was 232.1 and 349.7. That would be your next answer. You would type into the calculator. Okay, good there? Okay, so we did that in the calculator. I'll even put a little note here. Add x's together.
You just add the cosines to it and sine.
Now, if you got, did anybody get a different number than me? You could accidentally be in a radian mode. But yeah, you should have done these two, 400 cosine 50 plus 50 cosine 120. And then you do the 400 sine 50 plus the 50 sine 120. So you're adding together the x's together. Make sure you close the parentheses when you type them in. And then same thing on the y. Okay, are we good there? Okay. Add the y's together, add the x's together. Okay, then the next 3 things you should already know how to do from last class. We're going to find the speed. Well, the speed is just how long it is, which we already have a formula for. It's a squared plus b squared, and take the square root. So let's do that with our vector. So we're going to do 232.1 squared plus 349.7 squared, and then we're going to take the square root. So 232.1 squared plus 349.7 squared. Now, how fast did it say the plane was going? 400. How is it going 419 miles per hour? Because the wind's pushing it and making it go faster. Okay, so the engine's only making it go 400, but since it's going the same way as the wind is actually pushing it to go a little bit faster. Okay, so remember that speed and magnitude are the exact same thing. Okay, which we already know how to find it. It's just a different name for it. Okay, next thing we're going to find is going to be the direction. Okay, and the direction we already know how to find too. You're going to do inverse tan. Or we'll do tan theta equals y over x. And then we'll plug in our numbers. What's ry? What's ry in our vector? Which number?
349.
349. And then divided by 232. And then how do we cross out the tan? We did this as our little warm-up question. You do the inverse tan. So in the calculator, second tan, 349.7 divided by 232.1. Okay, my reference angle comes out to be 56 degrees. Now, for all of the vectors, you're going to round to the tens place, but for the theta, it tells you to round to the whole number. So I'm going to just round that to 56. Okay, that's called the reference angle. Okay, then the last thing you have to do is check your direction, okay, which probably some of us forgot, but I'm going to remind you. If you graph this vector, 232.1 and 349.7, what quadrant would you end up? Yeah, I'd go to the right and then I go up, right? I'd go this way 232, this way 349, and then my vector would be up there. Well, then think about, if my distance to here is 56 degrees, is that already measuring from the correct spot? Yes. But do you remember that for the other quadrants, there were little formulas that went in each one? Okay, so it's okay if you don't, but this quadrant, I'm already measuring from the start. So theta is my answer. Okay, so my reference angle is 56. Well, that's also my direction. Okay, now let's talk about what if you end up in a different quadrant. Okay, this one was theta. Does anybody remember the formula for quadrant 2? That was theta, 180 minus the theta. And then what about if I want to end up down here? 180 plus the theta. Good job, Shubi. And then what about if I want to end up in quadrant 4? I want to go all the way around, but then a little bit back. 360 minus the theta. Okay, so there's your chart. You have it on your notes from last week, but just in case you lost it, now you have it again. Okay, why did I not have to use a chart though this time? Because I was already in quadrant 1. And remember, quadrant 1's the preview. You get that, then you're good. Okay? All right, that's exactly what's on your homework. We're going to do one more through. We'll do one homework question together, and then y'all should be able to finish it on here. Okay, next question that we're going to do is going to be, we'll just do the next one, number 7. Okay, we want to write the velocity of the boat. Let's read what the boat's doing. It says the bearing is south 25 west at 500 miles per hour. Okay, then my boat vector is going to be 500 cosine theta, 500 sine theta. The problem is I don't know what my theta is because they gave it to me in this wacky form, but we know how to read it now. South 25 west means I'm going to start pointing south, and then I'm going to tilt 25 degrees to the west. Okay, so I'm going to start pointing south, which is how many? How many degrees is south? 270. But then I have to tilt 25 degrees west, which is this way. Should I add the 25 degrees, or should I subtract them if I tilt it this way? Subtract is correct. Think about why. Where do I always have to start? Here. And then I go around this way. So I don't want to include the 25. I need to stop early that way. Okay, so what would my direction be if I do 270 minus 25? 245. Okay, that's the boat. Now, the boat's not in a vacuum, it's in the ocean, and the ocean has water pushing it a certain way. Okay, so let's look at the tide. Okay, it says the tide is flowing 40 miles per hour, south 45 east. Well, then 40 miles per hour is how fast it's going. So 40 cosine theta, 40 sine theta. But then we need to figure out exactly what direction south 45 east is. Okay, south 45 east. So I'm going to draw my little compass. We already know that south is 270, but then I want to tilt towards the east, which is here. So that means I need to tilt this way. Do I add those extra 45 degrees or do I subtract them? You add them. So, and remember why? Because I have to start here and then rotate around the long way. So I'd have to pass through 270 and then go 45 more degrees. What would my direction be then for the tide? 315. Very good. So put 315 here, 315. Okay, so step 1, you're gonna write your vectors. Step 2, you're gonna add the vectors. How do we add them? X's with X's, Y's with Y's. Good, do it in your calculator. Okay, I'm gonna add these 2 first. I'm gonna add these 2 second. So I'm gonna do 500 cosine 245 plus 40 cosine 315. You should never be adding a cosine and a sine together. That should not happen. Okay, my X came out to negative 183. Negative 183. And then it's 0.0. Okay, but I'm rounding to the 10th place, so I'm gonna write the 0. Then I'm gonna do the same thing with the Y's. So I got negative 481.4. Okay, and then I'm gonna put here, how did I get those? I added the vectors to get that. Okay, after you add the vectors, is that not what you got? Wait, no, 40 is the miles per hour.
Oh.
45 is what we added to 270. You know what I mean? Okay, were those numbers right? So we all getting okay. All right, from here, graph this vector to see what quadrant it would be in. If I go negative 183 and then negative 481, what quadrant would I end up in? I'd go to the left 183, down 400, that would put me here. So I know for later that I'm going to be in quadrant 3. Okay. All right, next, I want to find the speed. Remember, speed is the same as magnitude. That's a squared plus b squared, then take the square root. Do I need the negatives for magnitude? No. Okay, because when you square, the negatives are going to fall off anyway. So 183 squared plus 481 squared. 481.4 squared. Okay, and my boat is now going 515 miles per hour. Okay, now it's only trying to go 500. Okay, but we can see that the water is actually helping it by making it go even faster. Okay, so it's going with the water. Okay, then your next step, you add the vectors, you're going to find the magnitude. Okay, then the next thing it's going to ask you for is the angle. Remember, you start with tan theta equals. Do I need the negatives for the tangent equation? No. And what number do I put on top of the 100 or the 400? 481 is the y over 183 is the x. And then how do I cross out the tan? Okay, inverse tan in the calculator. So second tan, 481.4 divided by 183 gives me 69 degrees. 69 degrees. If I'm in quadrant 1, that's my final answer. Am I in quadrant 1? What did we say? We're in quadrant 3. What was the formula then for quadrant 3? 180 plus. So for quadrant 3, my direction is 180 plus the theta. Okay, so what is 180 plus 69? 249. Okay, now let's remember the difference. What we just found is the direction. The first answer is called the reference angle. If you're in quadrant 1, though, then these answers will be the same. But if you're in a different quadrant, then you'll have to follow. Okay, overall, does that make sense? Okay, so open up your homework. We're going to work all the way through question 5. So I want you to open up 5A. And we're gonna work through. You should already have like a 20% on the homework, 25%, we're done. Okay? So you need your calculator out and you need question 5A up on your computer screen. 5A is this one right here. Okay, so here's what it says. First question. It says an airplane has a velocity of 400 miles per hour, 60 degrees west of north, when it encounters a wind stream with a velocity of blah, blah, blah. Which of the following is the direction of the plane? Okay, so all we have to do is pick. So look at your choices. Think about which one makes sense. I'm going to start off by drawing my compass. This is north. Never eat soggy waffles. I want to go 60 degrees west of north. How many degrees is north? 90. And then I want to go 60 degrees to the west. That means I want to go this way 60 degrees. Well, then should I add it or subtract it? What is 60 plus 90? 150. So you should be picking answer A. So everybody's picking answer A for 5A. And then we're going to go on. Good? Answer A, 150. Submit answer. Great, we got it right. Okay, next question, 5B. It says, write the component vector for the airplane. Okay, well, how fast is the vector going, we said? 400. And then what was the angle? Well, we had to add it to 90 though, right? 150 and then 400 sine 150. So just type it in, just like that. We're not going to put it in the calculator yet because it's only asking us right now to write the vector for the airplane. What are they going to ask us next? For the vector of the wind. Exactly right. So once you have this typed in, we're going into part C. Now it's going to ask me for the vector for the wind. Okay, and the vector for the wind, how fast is it going? 55, and it's going perfectly south. What angle is perfectly south? So it'd be 55 cosine 270, 55 sine 270. Okay, and the reason that it's broken up into pieces is so that if you get a piece wrong, you don't have to totally restart. You'll know what's wrong and fix it before you keep going. Okay, everybody good to there? So we have part A was A, part B, part C. What are we going to do with the vectors after we write both of them? We're going to add them. How do you add them? X with X and Y with Y. So pull up your calculator. Okay, and I'm going to type in my X's added together. So I had 400 cosine of 150 plus 55 cosine of 270. That's my X. I got negative 346. Okay, then I'm going to do the same thing for my Y's. 400 sine 150 plus 55 sine 270. So this is my X, this is my Y. So in the next question, when it asks me for the vector, that's what I'm going to type in. So I'm going into part B now. Okay, it says, write the resultant vector. That's when you add them up. And I'm going to type in those numbers on my calculator. Okay, so my first one was negative 346.4, comma, and then 145. Just like that. Got it to there? So we wrote the vectors, we added them. What are we going to do next? Well, actually, before direction, we're going to find how long it is. Okay? So go into the next question, and now we're going to find the magnitude. Okay, how do I find magnitude? I do a squared plus b squared, then I take the square root. So square root, I want 346.4 squared plus 145 squared. And then I'm going to take the square root. Now for this one, the plane was going 400, but it can really only go 375. Is the wind with it or against it then? If it was trying to go 400, but this is only going 375, then the wind is making it go slower, right? Okay, so your magnitude would be 375.5. Okay, because it's trying to go 400, but it's working against the wind. Okay, so push enter on that once you've got it. And then it's going to ask you for the direction next. Okay, how do we find direction? What do we put in the calculator? The inverse tan of what? How do I put it in? Y over X. My Y was the 145 over my X was the 346. Remember, no negatives on these or it'll come out wrong. Okay, I get 22.7 degrees. Now pay attention on your homework. It says round to the nearest whole degree. So what would 22.7 round to? 23 degrees. And then I need to check what quadrant I'm in for direction. So remember, that's the reference angle. Okay, so now let's go into our last question. 5D. I want you to think about which way this vector would be pointing. My X was negative 300. This was my X, this was my Y. What quadrant am I going to end up in if I go to the left and then I go up? Okay, I go to the left, 346, and then up. I'm in quadrant 2. What's the formula for quadrant 2? 180 minus the theta. And what was the theta? We just found it? 23. So what's 180 minus 23 degrees? 157. Okay. So I know it's kind of a lot of steps, but really it's not that hard if you just follow your notes. So it'd be 157. Okay? You can do it. Let's get your homework done so you don't have anything to worry about over the weekend. Yes, ma'am. They're giving you the direction, yeah. The only time you have to find is if it says like south 45 east or something like that. Because you have the old one, right? Yeah. All right, you can do it. Let's see what we're doing. Anybody need scratch paper? Yeah. All right, you can do it. Yes, take it out of your desk. All right, you can do it. You don't have to do it. That's easy. You're basically starting. And then what's the experiment? So, okay, now, if you square rooted 117, is it going to come out perfect? Square root. You square root. Well, I could 4 instead of 3. So right here, you want the exact value, then you're going to type in the square root of 117. So pull up the keyboard right here. And then pick the square root. And then just put a 117. And then put the 117 inside. So if it said round, yeah, you would do it. That one, since it says exact value, you have to type in the square root symbol.